Hello viewers, welcome to today mathematics class for this upcoming Post UTME examination. So if you're writing this upcoming Post UTME examination, you're preparing for this upcoming Post UTME examination, this class, this mathematics master class is for you. Do not joke with it. Do not joke with it. Because last year we did the same thing with our VIP class and they share a lot of testimony on this class. With this mathematics class, where we organize it. So we have a lot of questions to solve for you, so you can keep you prepared ahead of this upcoming Post UTME examination. Whether you are preparing for UNILAG, UNIBEN, or any university in this Nigerian, this master class is meant for you because we pick questions rather from the past question of all the universities. We have the past question with us. So I would like you to go to comment section. Let me know the university you are preparing for their Post UTME, and let me know in the comment section so we can do more research and to give you more questions that's related to your university, to the university of your choice. So the matter is this is more repeated with our research. We have found a lot of questions on this topic, and a question that's similar to this of different university past question we have with us. So that is why we claim that this is the most repeated question for Post UTME or for all in Nigeria, for all the university in Nigeria. So do not joke with it. Let's dive to it. So if it's the first time watching my video or view my channel, do way to subscribe, like, and share with your friends so they can benefit from this class. Please share this with your friends. Don't be too selfish. Share this video with your friends so you can help them out, that they can get access to this class. This class is VIP class, but we decided to make it free this year so people can benefit from it, and that is very important, guys. Please share with your friends. So if I see that it is moving, we can motivate us to do more research to make a video like this that can benefit for you guys. So let's quickly rush to it and then we solve the question. For this lesson 1, we have 2 questions to solve for it. So this is the first question. So immediately when I solve this question, I'll go to the next question and solve the next question. So let's dive to it. The question is, a solid is made up of a hemisphere of radius s centimeter and a cone of height s centimeter of the same radius as the hemisphere. What is the volume of the composite solid? So we're trying to find the volume of our composite solid. This topic is under mensuration. It's only about a plane shape. Okay. When you were discussing about maybe in SS1 or in your SS2, rather this SS2 and SS3 topic, mensuration, and talk about perimeter of area of a solid plane shape. So this question here is from that topic. So if you still remember, then you can solve this question. Can you give the question a try before I solve it? You can give it a try. You can let me know the answer in the comment section. You can pause the video and solve it in the comment section. Okay, so let's dive to it. Let me give you the step-by-step solution of it. So let's go to the solution. Let me read the question again and then I'll have the solution. A solid is made up of a hemisphere of radius. Okay, hemisphere of radius is given as s centimeter and a cone of height of what? S centimeter of the same radius as the hemisphere. They have the same. We have two shape here. We have a hemisphere, we have a cone, and the radius of a hemisphere is s centimeter, and the height of the cone is s centimeter. And say that of the same radius, mean that the radius of the cone is at the same radius as this hemisphere. Now, To solve this question now, if you don't know the formula of a hemisphere, a volume of a hemisphere, I don't know the formula for volume of a cone, you can't solve this question. There's no how you can solve this question. You can just get the option and the standard say you may get the answer correctly, and standard say you may not get the answer correctly. So that is why in mathematics there's some topic that you need to know their formula of it. So in case you have forgot, let me try to break it down. In this volume of a hemisphere, that was this volume of a hemisphere, let me say a VH, that's the volume of a hemisphere, is equal to, that is 2 over 3, okay, 2 over 3 pi r raised power of 3. So this is the volume of a hemisphere. Volume of a hemisphere is equal to 2 over 3 multiplied by pi r raised power of 3. That is volume of a hemisphere. Now, we also need the volume of a cone. So to volume of a cone, let me say the V, okay, the volume of a cone as VC, as the volume of a cone, is equal to 1 over 3, okay, multiplied by pi r square h. That is the volume of a cone. And sometimes some textbook will say it like this, it's some the same thing. Some textbook will say that pi r square h divided by 3. Some textbook will classify like that. It's still the same thing. And just like this one is a expansion from the expanded term, while this one is still derivation. So this one and this one is still the same thing. So don't get confused. That this one and this one are different. They are not different. Now, since we said that the volume of a hemisphere is equal to 2 over 3 pi r raised power 3, and also volume of a cone is equal to 1 over 3 pi r square multiplied by h, which is the height. So now the radius, the question said that the hemisphere has a radius of s. So let me try to bring something here. So the radius of the hemisphere, we have the radius is equal to what? S. And they said the radius of the height of the cone is what? Is s. So the height of the cone is equal to what? S also. Of the same radius, it means that the radius of this cone is at the same length as the radius of the hemisphere. So this one, r of this cone, is still the same thing as r of this hemisphere. They are both equal to what? S. Now let's put it into what we have here, and then we go to the let's first substitute into the volume of the hemisphere. So volume of the hemisphere is equal to, that is 2 over 3, okay, that's 2 over 3 pi r, and this r is equal to s. So let me put it as s with power, because it's with power 3 here. That's s with power of 3. Now, since we have this now, we have got our volume of a hemisphere, because we have substituted the value of radius as s, and it is with power 3 here. Now let's bring back to this volume of a cone. Volume of a cone, as we just saying that volume of a cone is equal to, in this place we have 1 over 3, okay, pi. You know that this r, the volume of a cone, has the same radius as the hemisphere, so mean that is s. Instead of writing this r here, we are saying as what? As s with power of 2, okay, multiplied by, okay, times, we have our h. Our height of the cone is equal to s, so is h with power of what? S. Instead of it to write h, I will be saying as what? As s. Now let's multiply together. You have s squared times s. That will give us s with power of 3. I get now. So mean that the volume of a cone is equal to 1 over 3 pi, 1 over 3 pi s was s cubed. I get now. Now let's find what is the volume of the composite. It means that we have to add what? The volume of the hemisphere and plus the volume of what? Of a cone. We write it together, and that will be the total volume of what? Of the solid shape. So that will be equal to that is total volume of a solid shape is equal to, we have the volume of a hemisphere, that is this, that is 2 over 3, okay, pi s with power of 3, okay, and also the second one we have plus, we add it together, the volume of what? Of a cone is equal to, that is 1 over 3, that is pi s raised power of 3. Now what you just have to do here is take the one that I like. We have the first term here, now the second term here. Okay, so what is common to this part and this part is pi s raised power 3. Pi s raised power 3 is one that common to this part and this part. So when you take it out, when you factorize it out now, so that means that we have a pi, okay, pi s raised power of 3, okay, open bracket. So when you used to divide this, means 2 over 3 here. You have 2 over 3 plus in this place also when you remove this part, so you miss 1 over 3, so because of 1 over 3, so close the bracket. So let me try to create space so we can see. So let's continue now. I think I have enough space now. So it means that the total volume is equal to, in this place now you have to find the LCM. So when you have two fractions, it is separated by equal to, or it is separated by plus, or it is separated by minus. What you just have to do here is to find the LCM of the denominator. So this one, let me write the output here. We have the pi s raised power 3 open brackets. Okay, the SL of 3 and 3 is 1. That is what? That is 3. That's over 3. 3 divided by 3, that is 1. 1 times 2, that is equal to what? 2. Plus 3 divided by 3, that is 1. 1 times 1, that is 1. So we have 1, here is plus. So let's close bracket. Now let's add it together. 2 plus 1, that is 3. So it means that the total volume of the solid surface is equal to, that is pi s raised power of 3, and this one goes that 2 plus 1, that is 3. That's 3 over 2. So we close brackets. 3 over 3 rather. So in this way, 3 over 3 that gives us 1, because 3 can go in 3, that produce as 1. I get now. So it means that the volume of a solid surface is equal to, we have a pi s raised power 3, because this one total 1. 1 times this will give us pi s raised power 3. So the answer should be pi s raised power 3. So let's look at the option, and then we choose the correct option for what we have here for the question. Okay, I think the option is option D, that is pi s raised power 3. So the best option is option D. So that is how you solve this question. So if you like the way I break it down, let me know in the comment section. So let's go to the next question, that is question 2. Okay guys, so here is the question 2. So we have the second question of today's lesson. So let's dive to it. The question is, the main sector of a circle of diameter 3.6 centimeters sustained angle 35 degrees. At the center, what is the perimeter of the sector? This question is still on the measuration, also is still on the plane shape. So in this place, we will also be discussing about the perimeter of a plane shape of a sector. So the question that I ask you, what are the perimeter of a sector? Okay, what is the sector? Well, let me try to draw a circle to illustrate what we have here. So this is the center of the circle. Okay, a line that joins for the point of a circle to any point of the circumference, it is called a radius. And the same thing, the line that from the center of the circle to any point of the circumference, it is called radius. So this part and this part is a radius. So the region between two radii, and a circumference, it is called a sector. The region here, it is called a sector. Now, this place to this place is called radius. This place to this place is called radius. You know, the perimeter is to find the addition of all these, this part, and all this part. Because here to this place, let's say here is point A, and here is point B, and let me say here is point C. The center of the circle is point C. So this way to this way is the radius, because a line that jumps from the center of the circle to any point of the circumference, it is called a radius. So the same thing from the center of the circle to any point of the circumference is called a radius. So this place we also have radius. And here For A to B here, it is a arc. Arc is any point of a circumference. Here to this way is a arc. So what will be the length of this arc? We don't know the length of this arc. Length of the arc is not given, but we're given the diameter of what? Of this circle. But we're not given the radius of this circle. So if you still remember, the formula of diameter is equal to 2 radius. If you have 2 radius, we give us a diameter. So if you still remember that the diameter is equal to, we have 2 radius. Now, if you want to get radius now, from this place, you can say that your radius is equal to d over 2. How did I get this d over 2? Because we have to make out your formula here. So you divide both sides by the coefficient of this half, that is 2. So when you divide this place by 2, you divide this by 2. So this 2 we cancel this 2 here. Now make radius, that will be d over 2. So to get the radius is equal to the diameter over 2. Then we get the formula for what? For radius. Before you find the parameter of the sector, you have to learn the length of this arc, and the length of arc is not given. We are given the angle sustained. The angle sustained here, it is equal to 35. It is equal to, sorry for this fashion there. So the angle sustained, the center of it is equal to 35. So we have 35 degree here at the angle here. So to get the length of the arc, length of arc is equal to theta over 360, okay, multiplied by 2 pi r. That is the formula to calculate the length of arc. Length of arc is equal to pi over 360, theta over 360 multiplied by 2 pi r. That's the formula to calculate the length of an arc. So when you get the length of arc, you can get a perimeter of what? Of this, the perimeter of this sector. Now let's provide it. So you know our theta is the angle. The angle is given as 35. So this is our theta. Let me write the data out. Theta is equal to, that's 35 degree, okay? And also we have a pi. A pi is a constant, and pi is equal to, either use 22 over 7, but I will use 3.142 in approximately 3.142 as my pi. So the next one we have the radius. Let's get our radius. You see our radius is equal to diameter over 2. So diameter is given as 3.6. So that will be equal to 3.6 divided by 2. We get our radius. 3.6 divided by 2. Let's give us 1.8 centimeter. So our radius is equal to 1.8 centimeter. So let's put it into this formula, and then input into this formula, and then we get our answer for the length of the arc. So let's put it down. So length of arc now is be equal to, that's theta, we have 35 divided by 360, okay, multiplied by, you have 2 pi, okay, our pi is equal to times, that is a 3.142 multiplied by the radius, that is 1.8. So let's use a calculation. Let's use a calculator, and then we solve it together. So you can first of all multiply all this and multiply. You can first of all multiply this part. 2 times 3.142 times 1.8. So let's do it. I will use my calculator to do it now. Equal to 11.3112. So that will be equal to, that is 35 over 360 is multiplied by 11.3112. That is, if we multiply 2 times 3.142 times 1.8, we have 11.3112. Now let's divide this, and then we will do the multiplication. So divide this out. 35 divided by 360. Here is 360, rather. 35 divided by 360. So let me quickly do it. That is 35 divided by 360. So that will give us 0.000 0.972 in approximately 0.972 in approximately. We have to do 2, but you have to leave it as 2. So multiplied by, we have 11.3112. Now let's multiply this both together and then we get our answer. So when you do multiplication now, let me try to bring it out. We have 0.0972, okay, multiplied by 11.3112. So that will give us our digit. So therefore, the length of an arc, is equal to as 1.0999, like that in approximating. So let's approximate into 1 decimal place. So when you approximate to 1 decimal place, so it means that this time will be approximated to 1 here. So that will be equal to the length of this one is approximated. Don't get this wrong. Yeah, the approximate to be equal to is 1.1 centimeter. So it means that the length of the arc is equal to 1.1 centimeter. So the length we have here, we have 1.1 centimeter as our length of arc of this sector. Now we have got the radius as 1.8 centimeter as our radius. Now let's find the perimeter of this one sector. Let me try to create space and then we proceed with it. So to find the perimeter of this sector, if you add all the parts, the distance here and B from A to C, C to B, B to A back, that's the perimeter of this sector. So let's say the perimeter, that is P and set PS is the perimeter of the center. We have the force here, that is radius 1, here to this place is radius, that's radius 1, okay, plus here to this place is radius 2, we have radius again, we have plus, and this is the length of the arc, we have what L what A, like LA we get here. So the radius, we get the radius as 1.18, that be equal to, so the perimeter of the sector is equal to 1.18, 0.8 plus 1.8, because the radius is 1.8 plus the area length of the of an arc is equal to 1.1. So let's add this together and then we get our answer. So let's say that's 1.8 plus 1.8, 1.8 plus 1.8 plus, that is 1.1, that will give us what, 4.7 centimeter. So it means that the perimeter of this sector is equal to 4.7 centimeter. So let's take a look of the option. So you can see the option is option B. So option B is the correct option to this question. So guys, if you enjoyed the class, I would like you to subscribe, like, also about it, in case what you benefit like this, you'll be the first to notify. And also share this video with your friend and family so they can benefit from this class for this upcoming post UTME examination. Please don't forget to share this video. If you have any question, go to the comment section and ask questions.